Okay, in the last video we talked about finding the derivative of the natural log of x. Today we're going to go backwards and we're going to integrate 1 over x. Now it can be common to fall into a trap here, so this is something that we just have to have memorized. Okay, the trap is it starts with finding the antiderivative of 1 over x squared. Okay, well, for us to do that you would have to rewrite it as x to the negative 2 power. Okay, so then when we do that, to actually take the antiderivative of that, you add 1 to the exponent. So you have x to the negative first, and then you have to also include the number in front that would be there if we were to actually take the derivative. So negative 1 times what number would give us this positive 1? Well, that would be negative 1. So you add 1 to the exponent, and then you figure out the coefficient. Okay, well, a common mistake would be to do that same process with this. Well, that would be x to the negative first. Okay, well, if you do that same process, you end up with adding 1 to the exponent, you get x to the 0 power, and then 0 times what would be 1, and you're like, wait a minute, what? Okay, so this doesn't work. You can't do that with 1 over x. So this is, like I said, you have to memorize this. You have to remember that the derivative of the natural log of x is 1 over x. So therefore, the antiderivative of 1 over x is the natural log of x. Okay, going the other way. But there is one little caveat with this. The natural log of x is a function that is only defined when x is greater than 0. You can't even put 0 into this function. Okay? So you have to be very, very careful, and that actually introduces absolute value bars around your x. Okay? So this right here is your antiderivative of 1 over x. So it's the natural log of the absolute value of x. Just don't forget those absolute value bars. It's more of a formality than anything else, but you do need to have those there. Okay? So we're going to start right away with an application problem. All right? Find the area of the region under the hyperbola xy is equal to 1 from x equals 1 to x equals 2. Area under the curve is an integral from 1 to 2 of xy is equal to 1. Now, it doesn't really matter that they're giving us a hyperbola here. Solve the equation for y by dividing both sides by x. So y is equal to 1 over x. Oh my goodness, that's where we get our function from, 1 over x dx. So, anti-differentiate 1 over x. Well, I just told you that's the natural log of the absolute value of x. So, what we have, the natural log of the absolute value of x evaluated from 1 to 2. All right, cool. So, natural log of 2 minus the natural log of 1. No, that does not equal the natural log of 1. It's just that's how you would write it, okay? And in fact, that's probably how answers are going to be given to you on the AP exam in terms of that. If it does ask you just to round your decimal or round your answer to 3 decimal places, then just type that into your calculator, okay? But you can do this without a calculator just by leaving your answer in terms of those natural logs there. So just natural log of 2 minus the natural log of 1, okay? Let's do a couple more. Evaluate the integral of x over x squared plus 1. Wait, this doesn't look like the last example. How on earth are we supposed to do this? Okay, well, this is where problem recognition comes in. Okay, super important skill. You see an x on the top, you see an x squared on the bottom. Okay, there's no way for us to integrate a quotient unless we use u substitution. Make the problem easier. Make it substitute u in for the x squared plus 1, the more complicated part of the integrand, and see what happens. Okay, du therefore is equal to 2x dx. Okay, now this is maybe making a little bit more sense. I have an x dx. I don't have a 2x dx, but I can get rid of this 2 easily. Okay, so I have 1/2 du is equal to x dx. So if I use my u substitution up here, I actually have the integral of 1 over 2. Okay, that's where the 1/2. Now instead of the x dx, that's gone away. I'm going to have du at the end. And instead of 1 over x squared plus 1, I now just have 1 over u. Okay. Property of integral says that a constant can be removed from the integral. So you actually can take that 1/2 out times the integral of 1 over u du. And now all of a sudden, hey, 1 over u, that looks like 1 over x. So now when you take the antiderivative of that, you get 1/2 times the natural log of the absolute value of u. Okay, it's an indefinite integral. Don't forget plus c. Okay, well, this isn't in terms of x. You just substitute your x squared plus 1 back in. So the integral of x over x squared plus 1 dx is actually 1/2 times the natural log of the absolute value of that x squared plus 1 plus c. Okay, don't forget u substitution. You have to know how to do that. Okay, last one. Evaluate or calculate the integral from 1 to e of the natural log of x over x dx. Again, doesn't look like anything that we've done before. However, make the problem easier. In this case, make your u substitution in for the natural log of x. Because if you notice, this x is in the denominator. And the derivative of u is 1 over x dx. Oh my goodness, okay, that's how this is going to cancel out. So after we make our u substitution, we just have the integral of u du. That's it. Because we've substituted the natural log of x out. We've substituted the x in the denominator and the dx out over here for the du. Okay, we could change the limits of integration, or not, because it's not going to be that big of a problem. Okay, this is u to the first power. So when we take the antiderivative of that, u to the second power, well, 2 times what would give us our coefficient 1? Well, it's reciprocal, 1/2. So 1/2 u squared. Before we evaluate it on our limits of integration, we do have to substitute back in. So it's actually 1/2 times the natural log of x squared, evaluated from 1 to e. All right, so when we do that, 1/2 times the natural log of e, that squared, minus 1/2 times the natural log of 1 squared over there. Okay, well, that's easy enough. The natural log of e to what power is e? Well, gosh, that's 1. So 1 squared is 1 times 1/2. That's just 1/2. Minus natural log of 1. E to what power is 1? Well, that's 0. So 0 squared is 0 times 1/2 is 0. Oh my goodness, this whole thing equals 1/2 after all of that? Yeah, it does. Okay, you can check it. Type it in. Y equals the natural log of x divided by x. When you graph it, you get that little guy right there. Calculate the integral from 1 to e, and sure enough, you get 0.5 or 1/2.